In the section 9.2, we applied the simplex method only to linear programming problems in standard form, where the objective function was to be maximized. In this section, we will extend this procedure to linear programming problems in which the objective function is to be minimized. Since we are familiar with the maximization problem, the idea of solving the minimization problem is to convert it to a maximization problem in the standard form, and then we can apply the simplex method as discussed in the previous section to solve it. So this box is the standard look of the minimization problem that we'll be learning in this course. Here we want to minimize w, which is a linear function of n variables s1 through sn, subject to all those constraints. As you can see that all the constraints are written with the inequality signs, okay? So we also are subjected to the non-negative constraints of each variable xi, and also all the constant terms on the right-hand side of each inequality must be non-negative. The idea of solving minimization problem by using the simplex method is as follows. Okay, we first form the augmented matrix for the given system of inequalities, and then at the bottom row we add the coefficients of each variable of the objective function. So by looking back to the problem, okay, those are the constraints. You put all the coefficients of variables in this portion of the augmented matrix, okay, to the left part of the augmented matrix. To the right part of the augmented matrix, you put all the constant terms of each constraint, okay? B1 through Bm are put in that. So the last row, or the bottom row, you put all the coefficients of each variable of your objective function. And at that spot, you put w, which is 0. When we first start minimizing the value of w, we set w be 0, like that. After we've got the augmented matrix, we then take the transpose of that augmented matrix. You know how to take the transpose matrix, don't you? Okay, we take the transpose. After we've got the transpose matrix, we can form the dual maximization problem, okay? So the bottom row will give us the maximization objective function, okay? And out of this portion and that portion, you get the corresponding constraints to your dual maximization problem. And the sign, the inequality sign will be changed. Previously in your original system, those are greater than or equals. After you have converted the problem to the maximization problem, the inequality signs will be changed to less than or equal. Okay, we are more familiar with this version. It's just the standard look of maximization problem, but we learned in section 9.2. Then we can apply the simplex method to this dual maximization problem. Okay, so the process after this will be exactly the same as what we learned in section 9.2. We'll get to understand the method better when we solve some problems.